Hello, my name is Justin and I'm doing my 60-day challenge today. I am going to chat to you guys about inverters. This is the hardest working part of the system. This is taking DC from the roof and this is putting out in AC current. This is the part of the system that has to work the hardest in my opinion, as the solar energy goes up and down throughout the day from dawn till dusk. The inverter is also monitoring and working in synchronization to the grid at the same time. So as the power is coming off the roof in DC, direct current, which will be a set voltage depending on your strings, that'll be putting into the inverter at a slightly different ampage as the day goes through. You'll be able to watch this on your monitoring and see it on your metering, as we referred to in an earlier video. But what is happening inside a synchronous inverter is he's watching either single phase or three phase, what each one of those phases is doing. And he has to stay within the tolerances in order to produce power and in order to produce voltage and current that is usable for the client. So every time the national grid goes up or goes down in its voltage or in its hertz, the inverter needs to follow that. So not only is our inverter working really hard to go from being nearly or completely off in the night and in the morning to being completely off again at night throughout the hardest working part of the day in the summer, quite a long summer in over here in England. Those panels are going to be producing a good amount of DC power, which the inverter then has to convert into AC, and as I mentioned earlier, synchronize with the grid. So this is doing measurements all the time to respond and react to exactly what the grid is doing. It can't push itself out of parameter. If the inverter goes out of parameter, it will drop into safe mode, stop generating. If the national grid in any way goes out of parameter, it will change and alter the hertz and the voltage to respond and react to cope with what the grid is doing. Now, in certain circumstances, if the inverter is not set up to the right country, we had a batch in the early years that was set for Italy, which is not the same as the UK grid standards. So we had to change all of those settings as we were setting them up on the day. Some inverters come completely blank and you have to tell the inverter what country it's in. Some inverters come thinking it's in America and all sorts of weird and wonderful, sometimes in Germany and France, all these weird grid settings come up on them. But our job as installers and as quality assessors is to make sure that that is set to the correct parameter so that it works within our grid specification. The national grid has a hard enough job as it is to keep within their parameter. They get charged and fined if they go outside of parameter. But part of the paperwork that we fill in when we're certifying a system that we submit to client and to the MCS would have within it what parameters we have set those inverters to. So if you're a little bit worried that the inverter's not set up correctly and running to the correct parameter, there's, depending on what make and model you've got, you can drop through the settings. There's so many makes and so many models of inverter that are available in the UK at the moment, and all of them connect differently to their monitoring and look differently to their monitoring. So one of the projects we've been working with at the moment is trying to get a universal look across portfolios and across multi-site installations to make sure that the end client sees one more monitoring portal, not 15 different monitoring portals, because they've had some solar panels installed 10 years ago and those are old inverters, right up with inverters that are getting micro inverters installed next week. They don't want to be logging into 4 and 5 different portals to see what's going off with those things. So I just thought I'd bring a little bit of clarity on the inverter side of things. One thing is when you get them installed for you, make sure you register the warranty on those inverters. If you can, if it should be in the handover pack, should be data that's given over to you from your installer. But that's one of those things that sometimes goes amiss in the hecticness of finishing a job and getting it all handover and getting it finished, is making sure that the inverter warranty has been registered. to you as a client, you as an end user, or in the instance of a standard domestic, sometimes you can just go and get the manual that's been left with you guys and register it yourselves. I'd always suggest that you make sure that that's so that you make sure it's registered, so that you can make sure that you've got access to the warranties that are available. Sometimes there's little policies within those warranties to state that the system has been maintained. That's something that we'll talk about in a later video. I really hope these videos are adding some value to you guys. If you're thinking about getting solar, then really check your inverter, make sure it's apples for apples, make sure those parameters are right. If you're installing new inverters, guys, make sure the MPP is right. Make sure the startup voltage is right. Do your calculations to make sure you're putting the right number of panels per string, to make sure that that inverter is coming online as early as it can for your clients. We'll talk about that a bit more in design. We'll talk about that in a design section. And we'll talk about that in stringing panels as well. So that's Justin. I hope that's adding value to you guys and opening your minds to the interesting world of solar and the crazy world of inverters. Thank you for your time.